Welcome to Lesson 10, Decisions, Logical Operators. In the previous lessons, you were introduced to the if statement, which allowed the program to make decisions on its own. The decisions were phrased as a question, which turned out to be the condition part of an if statement. We also explored the idea of an else, which is another component of the if statement, where if the condition, the question comes back no or false, we produce whatever, we execute whatever code is in the else clause. In this lesson, we're going to do something a little more sophisticated in that we're going to use the words and or in our condition as well. So let's get to it. So in a previous lesson, we had asked the user what the capital of New York was. So let's do that again. Of New York, which happens to be Albany. So the one challenge there is depending on how the person entered in the answer, they either got it correct or wrong. So let me give you the simple scenario. So let's say you did something like this. City equals Albany. And if they got it correct, you simply wrote print correct. And then let's say if you get it wrong, you could write print no, put that in quotations, no, the capital of New York is Albany. Okay, so let's just try it out. Bring this over a little bit. Let's go ahead and run it. Okay, so enter capital of New York. I'm going to get it correct. Albany says correct. I'm going to run it again. But this time, I'm going to do it like this. Albany, which technically is the right answer. But when you look at our if statement, our question is asking, is city equal to Albany, capital A-L-B-A-N-Y? And a computer's stupid. It's going to do an exact match. So you're going to see that this is going to come back incorrect. So what we could do here, we could do a couple of things. We could create another if statement that kind of checks for the right answer. But that's not necessarily the most efficient way of doing it. And I'm going to phrase the question a little bit different. And hopefully you could pick up on the word that I'm using. So if city is equal to Albany with a capital A, or city equal to Albany with a lowercase a, then the answer is correct. So in Python, unlike some other languages, you can actually use the word or, which is beautiful. It makes the program very readable, which was one of the goals when they first created Python. So we'll say city, Albany. So now the idea is that if the city is equal to this or the city is equal to that, then we're going to print out correct. Let's try it out. So I'm going to do Albany with lowercase a, hit enter. Hey, I got it correct. I'm going to run it again with a capital A. I'm going to get it correct as well. So the way the or statement works is as long, and actually, I'm going to do this as a comment. Or as long as one of the conditions is true, yes, then the whole condition is true. So in this particular case, when we looked at when the person entered in Albany, it said if city is equal to Albany. Well, it was. So our answer is correct. In the previous example, when city equal to Albany, when we did a lower, matter of fact, let me just run it. Be easier. when you do this, you ask yourself, did city equal to Albany with a capital A? The answer is no. But city did equal Albany with a lowercase a. So as long as one of the two sides, honestly, what the OR is doing is asking two questions in one shot. So as long as one of the two questions comes back as yes, the whole thing is correct. Okay, so that is how you use the word or. The fact that as long as one of the two conditions is true, the whole thing is true. And then you actually do this part of the if statement. I would definitely suggest when you read a scenario, look for the word or being used in the description. If you see the word or being used in the description, that's a dead giveaway that you should probably be using or as part of your if statement. If you recall, I said that programming is an extension of our natural language. So it makes sense for us to be able to program in the same way. All right, so for this next example, I'm going to keep it a little more straightforward, not very a practical solution. And then I'll end up with a nice, cool, practical solution. So let's ask the user for two numbers. And we'll do int input enter number 1, colon space, and we'll just do this. So we'll say 2. And I'm just going to go right in here and immerse you into the next concept. So listen to the scenario I'm putting. So if number 1 is equal to 5 and number 2 is greater than 20, I want to display hooray. All right, so let's go through that again. So if you notice the words that I use, so I said if number 1 is equal to 5 and so you can actually write the word and. Number 2 is greater than 20, I want to do something. And what I want to do is I want to print hooray. Else, we're going to print boo. Okay? So let's run the example. And what I'm going to do is I'm going to comment out this first code just so we don't have to keep going through that one again. All right, so we're going to ask for two numbers. Number 1, I'm going to put, let's enter 5. And for number 2, let's enter 21. We get hooray. And let's talk about why we get hooray. Well, we get hooray because number 1, well, let's phrase it like a question. Is number 1 equal to 5? Well, it was. The person entered 5. And is number 2 greater than 20? Well, yeah, it is. It's 21. So, you know what? Let's write the description of this. So, and all conditions must be true in order for the whole condition to be true. Okay, so I'm not sure if you realize that this is what I mean by the whole condition. Both these smaller conditions together. So the whole condition is actually being composed of smaller conditions, smaller questions. So the big question is number 5 equal to is number 1 equal to 5 and number 2 equal to greater than 20? That's the whole question. The mini questions are, is number 1 equal to 5 and is number 2 greater than 20? Greater than 20. So I'm going to run the program again, except this time we're going to mix it up. Let's say I do enter 5 for number 1. So that means that this side will be true. But then let's not get this side. Let's enter 10. It says boo. Let's see why it says boo. Number 1 was equal to 5, so that is a yes. But then the person entered in 10. Is 10 greater than 20? No, it's not. And if you look at our definition, both sides have to be true. Both answers to the questions have to be yes. All right? Let's run it again. And this time, let's get the first one wrong and the second one right. So you're going to notice it's going to say boo again. Reason being, well, we failed the first question. Is number 1 equal to 5? No, it's 10. So this answer is no. So at that point, the computer doesn't even bother with the other side because it realizes that with an and, both sides have to be yes, true. This is part of a higher concept called short-circuiting, but just realize right now that because one of the two questions turned out to be false, a no, then the whole condition is no. In order for this to work, both sides have to be true. So let's run it one more time, and let's get nothing correct. So let's say 6. It says boo. Well, what's our question? Is number 1 equal to 5? No, it was equal to 3. And is number 2 greater than 20? No, it's not. 6 is not greater than 20. So in this case, neither side worked. And honestly, if you think back to your own lives when you use the word and, it's very natural. It's a conjunction. You're comparing two things having to be at the same time. So if it's Saturday and sunny outside, then we'll go out and play. So think about it. If it's Friday, are you going to go out and play? No, because it said it had to be Saturday. Let's say it is Saturday, but it's raining. Are you going to go out and play? No. Again, so the notion of and, you're already familiar with. The fact that it has to be both conditions. Now, similar thing, you could do a similar analogy with the or, that, let's say if it's Saturday or Sunday, we'll go out to play. So let's talk about, if it's Friday. Well, because we didn't explore that example with the Albany problem. For an or statement, at least one of them has to be true. So if today is Friday, but we're saying that we're going to go out to play on Saturday or Sunday, then we're not going out to play because it's neither Saturday or Sunday. So let's say it's Saturday. Well, if it's Saturday, then yeah, today is Saturday, we go out to play. I don't really care so much that it's not Sunday. Hey, as long as it's Saturday or Sunday, one of the two days, we're going to go out to play. So I definitely encourage you that as you start going through these if statements, listen to yourself and think about what you want to say if you were just talking to somebody. Because then the code's going to come out very close to it. All right, so let's go back to the presentation. And in this lesson, we covered decisions. We reviewed the concept of else as a way to produce a different output when the question's not correct. But we enhanced our questions by being able to use the word and or to create more complex questions. Ones where either two things had to be met or at least one. All right, good luck. Thank you.